consider using the term of the world that the place
There won't be a ton on the whiteboard, and it'll be chicken scratch anyways, and nobody can read, so it's more for me to think out loud. Yeah.
We're still kind of nailing down how to do the Byte session. So.
Oh, yeah.
Hey guys, we're gonna get started. Welcome to a Byte session. So glad you're here. There's so many of you. It's amazing. I know we're kind of buried in the first part of winter term, which can kind of feel, oh, we all know how it feels. So anyways, thanks for sharing your time with us. We are Hacker Refactor. Linnea is here, our president. I'm Kimberly, and we're a club here on campus dedicated to promoting diversity, equity, inclusion in STEM, in computer science, and engineering, all of those related things. We want to provide a place where you can practice skills that you're going to use in the real world and where you can belong, because sometimes in an engineering field, we can feel like we don't belong. It's very exclusive. So you all belong, and we're glad that you're here. So Orion is our guest speaker this week. Oh, before I forget, Byte sessions serve as inquiry and collaboration for your professional development. So don't forget to do like a little write-up so you can earn some points. Don't forget to use the little scan code to let us know you were here so we can fund the snacks. And with that being said, Orion is here. He's a senior in the computer science department. We're stoked that he's joining. He's working on a couple of really cool projects. One involved hydrology test. There's a big
River flow rate forecasting based on weather data.
Which helps kayakers.
Personal bias.
Yep, because he's also a big time traveler. And then he's going to talk to us about a little help from our AI friends, because of course we all need that. Or maybe, I don't know. We're going to find out. So let's make Orion welcome.
All righty. So I'm here to talk a little bit about large language models. So these have been around for a long time, all the way back to the 70s, 60s even. But they've very recently gotten good enough to be super powerful. So this is something called ChatGPT. Who here, raise your hand, has heard of ChatGPT or GPT-3? All right, pretty much everybody. Who's used it, like actually opened an account and played with it? All right. So this is kind of the current state of the art. So there's a lot of powerful things that this can do. I'm going to show you kind of the way I think about using this as a little assistant for coding and just work in general today, but I'm also going to show you a lot of the pitfalls and things to watch out for. And I think it's really essential that in order to use these tools effectively, you have to have some understanding of what they're doing under the hood. So I'm going to start off with kind of this very simple, kind of the very minimalist brute force approach to large language models, and then try to walk forward to what makes ChatGPT different, to kind of explain how these things are working under the hood. So the general class that GPT fits into is called a large language model. So to give you a little bit of a textbook definition from Wikipedia, that is just a language model is a probability distribution over sequences of words. I promise I'll keep math to a minimum. But all it does is that given any sequence of words, a language model assigns some probability, P, to the whole sequence. So that's not super intuitive, but let's kind of use an example and build up a brute force language model to kind of build our intuition. So imagine we're reading 1,000 words. Every time we get to a word, we're going to add a tally. Let's say that it says bee, dog, bark. So when we see, that's our first sentence, we're going to put a tally by bee, tally by dog, tally by barks. Next time, let's say the next sentence is the dog ran. We're going to put another tally by bee, another tally by dog, and create a new word for ran with one tally, and kind of so on and so forth. So if we're kind of building up this lookup table, how often these words are showing up in our text. We're counting the frequency of every different unique word. And so the probability, what our language model does, is it just says, hey, how many times out of our 1,000 words we read did that particular word occur? So let's say that in our 1,000 words, the word and, pretty common word, showed up 43 times. The probability of and is 43 over 1,000. Whereas flabbergast, maybe not as common of a word, showed up twice. I'm not quite sure what we're reading in this situation that talks about dogs and the word flabbergast, but bear with me. So we can say that the probability of and is greater than the probability of flabbergast. Under the hood, that's all the language model does. It's just taking in a sequence and saying how common it is, how likely is this based on some amount of text that I've read. So it can go a little bit further though, is it can handle multiple words. So let's kind of keep going with this example. So within each of these lookup tables, let's say now we're doing one for 2 words. So erase all of this. So within the word the, we're now going to have a kind of a subtable here for every word that's followed the word the. So we might have the dog, maybe later we saw the cat, and we've seen the dog twice and the cat once. It kind of makes sense how you can build this multi-layered lookup table for handling longer sequences of words and just do the exact same thing. It's not restricted to the single words. So for example, and then is going to be more common than and flabbergasted. So again, we can say which is more probable, which is more common, which is more likely based on this corpus of text that we've trained our model on. So to take this one step further, we can now talk about generative language models. So say we have this string of dogs are the most blank. I mean, what comes to your mind? Maybe dogs are the most loyal or friendly, whatever it might be. You can imagine we had a lookup table like this. That'd be a couple layers deep. So we have dog, some other words here. Let's just say are the most. So there'd be other branches here, other words that have followed dog, other branches of things that have followed dogs are, like dogs are friendly, dogs are nice, whatever it may be. But dogs are the most blank. And so let's say that we train our model on just one source. We're only going to give it this one Wikipedia page about dogs. That's our entire corpus that we're training this language model on. So this is a very nicely cherry-picked example because it happens that dogs are the most shows up a few times. We have dogs are the most variable. We'll add that. Some of this, sorry. Dogs are the most variable. Shows up once. What else we got? We got dogs are the most abundant. Once. What else shows up here? Dogs are the most abundant again. This is a cherry-picked example, and dogs are the most important. Once. And again, this is all we're training on. Those are the only samples that show up. So that's all we're working with. How do I go back to full screen here? So now we have this language model again, and it's not just tallying for this, it's tallied up for everything else we read in that entire Wikipedia article. But now for this phrase, we're trying to generate text. We want to say, well, what would fill in this blank? What makes sense to fill in this blank? We can just go through the entire dictionary. Aardvark, we never saw it. Abacterial, never saw it. Abessive, never saw it. Abhorrent, never saw it. Abundant, that's a 1 in 4 chance. There's a probability of 1 in 4 that it's abundant. And we keep going, so on and so forth. All the way until we decide that abundant is our most probable thing. So that's what we would generate in the string with this generative large language model. And something that does this all the time is your phone's keyboard. It's been doing it for years. And you're typing in words, it's pretty much all that that's doing, or at least in the early days. It might be doing more clever things at this point, but early generations of iPhone keyboards were just doing something like this. Big frequency tables, there might be some more clever efficiency things, but they're just looking up what's most likely to come next. So kind of what's the problem here? The catch is that generating P is really, really hard. So in calculating the probability, it's exponentially harder as the sequence length increases. We have about 170,000 words in English. So a 2-word sequence, to build that 2-word lookup table, just dogs are with the entire English language, is going to be 170,000 squared possibilities that we have to keep track of in our frequency table. We want to do a 3-word sequence, it's going to be 4.9 times 10 to the 15 probabilities. 4-word sequence, massive. So we need something better than our brute force approach. How can we do better? So there's a few, and again, I'm going to skip forward a little bit here just to get closer to ChatGPT. A lot of people tried different clever things along the way, other shortcuts to make these lookups more efficient. There's even some clever neural network stuff that started happening in the mid-2010s. I'm going to kind of skip over that and just go to the state of the art. So let's find a better example that we can learn from. There's actually a lot of really good large language models in this room. Can anybody point to one? Kind of right. How many do you think there are in this room? Well, how many of us are there? So your brain is a really, really freaking good large language model. It's not just trained on one Wikipedia article, it's trained on every sentence you've ever heard, every book you've ever read, every PowerPoint slide you've ever seen in a Byte session on campus. Every single one of these strings has been put into your brain. So you can intuitively say, if I ask you which of these is more probable, and then, or and flabbergasted, you've probably read the words and then more than you've read the words and flabbergasted. You might say that and flabbergasted is reasonable. It kind of makes sense, but it's less likely. So the trick is, how do you know? And that's kind of goes back to that. You've just seen all these things over the years and you've built an intuition. But remember that limitation, how the naive brute force approach doesn't really work for long strings. So your brain is a really good large language model. I'll show you what I mean. So let's say we have the sentence, I really want to get to know Heather, who I sit next to in my engineering class, but I've always been too scared to introduce myself. I do not know if I'll ever have the courage, but someday I would really like to talk to blank. Shout it out. What do you think fills it in? Yeah, so maybe like talk to my friends or maybe your mom about flirting advice because your mom's really good at that. Maybe I would reuse Heather, maybe they use he, him, or they, them pronouns, but her is going to be the most likely choice. So can we make a better LLM kind of learning from how our brains did that? Brute forcing that last sequence is hard. Again, it's a search space of 100, I think it's about 50 words, 170,000 to the 50th. Our lookup table is done. That's never going to happen. It's not possible. That's really hard, like effectively impossible. Don't even try, no matter how many supercomputers you have, it's just not worth it. So can we do better than brute force? Let's think about how your brain did better at that. If we go back to that thing, you didn't care about every word. Your brain picked apart what mattered. You paid attention to what mattered. So of this whole sentence, like the fact that you want to get to know Heather might not matter. Sitting next to her in your engineering class, irrelevant. You've been too scared to introduce yourself, irrelevant. You don't know if you have the courage, but someday you would really, a lot of those words aren't needed. So what matters? You might pull out the fact that you know Heather and you talk to blank. This bottom string is way shorter, way more concise, something that a computer could actually handle. And semantically, it gets across all of that same meaning. So in way fewer words, really what fills in this blank is going to be about the same as what fills in the blank for the much longer string. So you're able to look at that long string and pick apart the few keywords that matter. So again, I'm skipping over a lot of history. There were a lot of clever things, recurrent neural networks. If you want to have a long rant about that, I can do that with you later. But really, this was the key insight that's made things like GPT-3 possible, is this paper from Google and University of Toronto in 2017 called Attention is All You Need. This is a very technical paper. I'm happy to try to walk through this later with some of you if you're interested. I'm not going to do that now, just to kind of keep this talk a little bit more accessible. The core principle here is they made a mechanism that can handle these long strings, figure out what parts of those really long strings are relevant, and get rid of the rest. So they're able to have this efficient representation of what a sentence means and what parts of it matter in order to do these generative things. So this was in 2017, this paper came out, and it really kind of sparked a new era. This is a whole new approach. And this is kind of two key things here, is that it handles long input sequences. So we can now deal with much longer pieces of text without overflowing our computer. And it's also something that can be run in parallel. This might be a new concept for some of you, but kind of in brief, this is a very big field. But imagine we have some process that has 10 steps to it. Every step takes 5 seconds. Something that is a serial process, or has to be run in serial order, that we cannot parallelize, means we have to run step 1, then do step 2, then do step 3. So if every step takes 5 seconds, it's going to take 50 seconds to do 10 steps. If there's 100 steps, it's going to take 500 seconds. The key thing they introduced here is their approach can be run in parallel. So if we have 10 steps and we have 10 computers, I give 1 step to each computer. It still takes 5 seconds per step, but each computer can do it at the same time, and they all come back to me with their results. If I can do 10 steps in 5 seconds, I can do 100 steps in 5 seconds. I can do 10,000 steps in 5 seconds if I have 10,000 computers. So those are kind of the two things that made this suddenly just so magical. And so it gets better with more data and more compute power. So the more computers I have, the more of those steps I can do concurrently, the better I can make this model. So researchers kind of agreed, like, yeah, you throw more computers at it, it'll get better. But surely that's like say there's some graph here, if it gets better and better, the more compute resources. But at some point, you're going to get diminishing returns. Like compute power will only take you so far, surely. And that's probably true. We just haven't found that threshold. So they released this in 2017. People made really clever models out of it. They said, hey, this is doing pretty dang good. What if we go bigger? And it did better. Like, what if we go bigger? And it did better. Like, what if we go bigger? And it did better. And they have not reached this point of diminishing returns. So these bigger and bigger supercomputing clusters just keep making better and better models. So GPT-3 is kind of the current state of the art. And really, it didn't introduce that much new stuff. It wasn't some crazy conceptual breakthrough. It wasn't some wild, outlandish way of thinking about the problem domain. Like they did a couple of clever things. You get into the nitty-gritty. But effectively, they just did everything that was introduced in 2017 in that Google paper. That's all they were really basing it on. But they used a shit ton of computers. It was $13 million just to run the servers to train this thing, like months of Microsoft just throwing massive server farms of this thing. So it's huge amounts of compute. And they're giving it massive amounts of data. So they gave this a huge fraction of the internet. They have actually kind of a funny collection algorithm where anything on Reddit that got more than 3 upvotes, scrape all of that because they were deemed that that's better than anything that got downvoted, apparently. Kind of some interesting things to get into on that. They grabbed all of Wikipedia because they're kind of expecting that to be somewhat curated, and thousands and thousands of textbooks, history books, things that are kind of deemed decent things to train on, like probably true, accurate, thoughtful information. So this is a graph, it's a little bit blurry, but kind of shows that transition in model size. So down here on the left was right after the paper got released. Allen Institute for AI2, they released a pretty clever model based on it. That was somewhere down here. So as we go higher on this graph, we're talking about more parameters, so a bigger model. It takes more to train. OpenAI did GPT-1 right here. AI2 had another crack at it. GPT-2 is down here. Microsoft, Facebook all had these kind of cool models at times, all generally based in this 2017 paper. Microsoft was fine, like, screw it, 15 billion, let's go huge. And these models just kept getting better. And so OpenAI was like, all right, Microsoft, how much money do you have? Like, let's just see how far we can go. And so they made 175 billion parameters. So it's kind of like AX plus BX plus C, but instead of 3 coefficients, you have 175 billion. For reference, your brain has about 120 billion connections in it. So depending on how you measure it, there's more connections in this model than there are connections in your brain. And this is a little bit of a technical graph. I'll do my best to simplify it, but it just keeps getting better. So that diminishing returns, we don't know. We are not here yet. Maybe GPT-3 is right here. It's about to level off. Maybe it's down here, and all those other models were playing around in this space. So what this graph shows is validation loss, basically how often a model screws up on the left here. So as we get lower numbers, those models are doing better. The x-axis is how much computing power we've thrown at this. Basically, is how long are we training it for? So you would expect that as you train it for more, it gets better, which all these are doing. Then every line here is a different model with different numbers of parameters. So this yellow model is something like GPT-3, really, really big. The purple model, something quite a bit smaller, maybe those earlier versions. As you can see, all of these models, as you throw more computing power, they get better and better and better, but they all kind of plateau somewhere until you throw more parameters at it. And the next one gets a little bit better, a little bit lower loss, but then it still plateaus. So again, the scientists are kind of saying, like, you'll hit some point where no matter how many more parameters you add, there's some horizontal asymptote that these are all going to converge on. There's some place that just with this attention design, you can't do better than this threshold, surely. But every model keeps getting better and better. These green ones are a little better than the turquoise, and this yellow one is still shooting downward in loss. So more parameters, more compute power, more smarter AI, just better. It just still is working like that. So that kind of brings us to where we are today with GPT-3, which is the current state of the art. So again, there hasn't been a major conceptual breakthrough. They're just throwing more computing power than anybody has before. And chances are GPT, they're on 3.5 now. It's not really a full version, but GPT-4 will be out before too long. And they're just throwing more at it. I think Microsoft put in $10 billion a couple of weeks ago of additional funding for OpenAI. So they're still just throwing money at this. Like, they're seeing this trend. If more computers makes it smarter, all right, here's more computers. And they're investing really, really heavily in that. So there are some incredible capabilities to this. If you've played with it, you already know. If you haven't, then we're going to play with it a little bit today. You'll see some of that in action, but it is limited. These models have gotten very, very good, but they do not do everything. So there's absolutely no fact checking. It can say something that is totally wrong, and it's going to very, very confidently tell you that. I'll show you a couple examples of this. But one place that comes up is math and logical reasoning. So it's only a language model. Remember, back to our very basic brute force language model of just saying how likely, like what's the most likely next word. That's all GPT-3 does. It says, what's the most likely next word? It's never backing up and saying, wait a minute, is this sentence true? Is this sentence factual? Is this math equation I wrote out true? You might say, what is 2 to the 50th power? And it finds somewhere on Reddit that 2 to the 50th power equals bananas. And if that was typed enough times on Reddit with enough upvotes, it would say bananas. And it would be confident that that is the answer for 2 to the 50th power. So it doesn't necessarily know anything other than the words spitting out, and it doesn't check them. It's also very expensive. Obviously, you need a lot of resources to train. Even running inference on this model, like kind of generating an output, requires a lot. So it's not really accessible for all domains. And some of these limitations are being addressed. I'll show you kind of an interesting integration where they're mixing it with basically Wolfram Alpha, a really intelligent calculator. So there are ways that this fact checking and this language are getting addressed. And down the road, these things probably will get better and better. And some of these things will be smaller problems. But I think it's really, really important to recognize what these limitations are at any given time while you're using these tools. These tools aren't going away. I think Andrei Kropotny, he's a programmer that works for Tesla. He's one of their main people building the self-driving cars. He said about 80% of his code today is written by AIs, GitHub Copilot in particular, so these things are going to be a part of your life. You're going to use these every single day in your jobs more than likely, especially if you're good at your job. It is a way to be more efficient. It's a way to do more in less time and cut out some of the simple, boring tasks. But you have to be aware of the limitations. So that's some of what I'm going to show you now. Hopefully, still there. Let's find out. Sometimes their servers get overloaded, so you can't always access this. We'll see if it's running fast enough to use. Otherwise, I do have live recorded demos. Let's see if I can get a chat going. So I'm going to start off showing you guys a couple of bad examples, if you will. I might have to go to recording ones because so many people are using this all the time that it just gets overloaded and you can't always access it. Let me try the new chat. Say hello. One message at a time, of course. One more try, and we'll give up on this. Oh, that's not quite as good. Didn't understand what I mean by hell. Okay, there we go. So I'm going to show you a bad example. So I kind of got you all here on the clickbait of, let me show you how to cheat on your homework, and you all fell for it. And now you're stuck in a lecture about machine learning. Haha, joke's on you. So let's say that this had been the lecture you were all doing. It was about how to cheat on your homework. And you walk out of there being like, man, these AIs are so smart. They can do whatever for me. They got the whole internet. They got all Wikipedia in there. All right, I got to write an essay about the Spanish or the French invasion of Spain and how that destabilized the colonies that Spain had in Central America. So let's see if it can do that. So write me a 5-paragraph essay about how the French invasion, my A key is broken, so I'll type a lot of double A's, of Spain led to revolutions in the colonies. Let me see what it does. And wow, right away, the French invasion of Spain in 1808 had a significant impact on the colonies, and you'll see the revolutions and uprisings, yada, yada, yada. And it just does it. And this is pretty good English. It's pretty thoughtful. It is probably pulling this from textbooks. It's probably pulling this from different sources throughout the internet, Wikipedia, and it's kind of crowdsourcing those sources. Even if one false Reddit was saying that Putin time traveled back to 1808, it's not going to listen to that one because there's 10 other ones saying what actually happened. So this is pretty dang good. And let's see, we got some good stuff about Creole. All right, let's say I want a little bit more information. Give me more info and context on, I don't know, the impacts on indigenous and mixed race peoples in the Americas. Like double A coming through again. And let's see if it can do that. So immediately gives me a paragraph on that. It can do that. What are some of the problems here? Yeah.
Does it recognize the first request you made? Did you make the second
Yep.
request? It does.
So there I was kind of not super specific, so it kind of just ran with that. But if I could say add a 2-paragraph summary, my dang A key, of that information into the first 5-paragraph essay you wrote me. If I could still generating, so it might take a second. Yeah, and so now it's adding those in as additional paragraphs to that first essay. Knows the context of what I wrote before. Yeah.
Let's say there's 3 other students who is having reading this and they need to generate the same essay. So you can generate the same 5-paragraph essay for everything.
This is an interesting point. So kind of the broader questions, to back up for a minute, I'll come back to that, is this plagiarism? Everybody close your eyes, raise your hand if you think this is plagiarism. Yep, there we go. So this is not original work, first of all. It's an AI's work, but is it even an AI's work? This thing is just generating word for word for word for word. It's generating whatever comes next in a sequence. So there's a solid chance it's pulling entire sentences or even entire paragraphs from other books. I think, let me show you, this is the demo I had recorded just because it has a nice example. So you can even tell it, add MLA in-text citations to the key points. And it just does it. Smith, one, Jones, even gives me a references page. But you go and you grab one of those references, Smith, John, the Creole Revolutions in America, Journal of Latin American, doesn't exist. Does that journal exist? All right, the journal exists. That's pretty good. Does that author exist on that journal ever? No, not at all. Does the issue of the journal that we cited exist? Not at all. But spitting out what looks like a really good essay for what it is. I could probably get you a decent grade in a writing 121 class that a lot of you might be taking, but the MLA citations are totally bogus. They're not even real sources. So then back to your question of would 2 students generate the same thing? So there's a little bit going on under the hood of explaining this up a little bit. So with the raw model, there's a slider you can affect. So you can tell it how much stochasticity, how much randomness to insert in the system. So you can tell it none. You can tell it be totally deterministic. So if I give you the same prompt, it's always going to give me back the same answer if I set that to 0. If I have that slider all the way up, then maybe based on the time of day or just how it's feeling at that exact moment, because this thing's sentient under the hood, it's actually just a little fairy in a server farm somewhere, and it's having a rough day, didn't have its morning coffee, then it'll just give it a slightly different way. But even then, if I had that slid all the way to fully deterministic, give me the same output, it's only going to give me the same output for the exact same request, like word for word, the same input. So we can even try it. Let's go back to our very first thing. I guess I don't need to run it through, but it will probably have subtle differences, but it'll generally be the same content, probably the same structure, especially if you type in the same thing word for word. But you can say, write me a 5-paragraph essay in a, I don't know, professional tone with an emphasis on Napoleon's motives. That's still close enough. For the invasion of Spain. So I had that little bit of a qualifier on the end, and it's going to totally change how this writes. So again, it kind of started the same, but already here, it's talking about Napoleon's brother, Joseph Bonaparte, is bringing in new content that wasn't in the original essay. So I think to answer your question of how you would have your essay look different from your students you're trying to cheat with ChatGPT, I guess make your queries very different, but back to the bigger point, it's still plagiarism because you're still pulling this word for word indirectly, albeit from another source. It's just copying out of whatever else is online, probably Wikipedia. And any citation it gives you has nothing to do with that. Like it's clever. It knows like my MLA citation should be from a journal. It even found a real journal. That's pretty good, but it's not an essay or not a copy of that journal that existed or was ever published. And this would definitely get flagged by Turnitin before you get any clever ideas. And beyond that, there are already toolkits for teachers that detect AI generated work. They are already in usage. There have already been cases at Cascades of students getting caught for this. Don't get any ideas. My title was clickbait. I got to have that disclaimer. You will fail classes and get expelled. So let's back up a little bit though. And let's try to do this with code. So I'm just going to do a recorded demo because I know it does what I want. None of that non-deterministic stuff, but let's say that I'm working some job, and let's see, I'm going to take an example from my work. So we're doing river forecasting stuff. So there's a river forecast put out by NOAA, and my boss, I've bluffed my way through several years of computer science work. So I got ChatGPT to write all my homework assignments for me. I think I'm pretty smart. My grades are great. None of my teachers ever caught me. I get a job because I've done so much cool stuff in Python. And my first day on the job, I need to give a graph. Where's my graph? There we go. Where my boss says, hey, I want you to go create a Python function because your resume says you're good in Python. You clearly study all these classes in Python. I want you to go download this HTML file and parse it into a data frame in Python. Okay, that's the example we're going to work with. So we need to grab all this data, and data frame is basically just like imagine an Excel spreadsheet, but it's in Python. You can kind of play with it with code really easily. So I'm able to do it just from my memory, or a quick Google search. I'm able to like get the HTML file downloaded. That wasn't too bad. I'm able to load it, but now I'm having a problem where the index of my thing is, it's not a date. It's just this month/day and a time. Now that's not very useful for me because my boss says I need to know what the time zone is. My boss says it needs to have a year attached to it. So I'm like, all right, I need to make it a date time object is what we're going to call that. Close a couple of things here. So just to show you kind of an example of what that data might look like, we'd have column or data frame, something like this one here, where see on my index is just this string where it's month/day with a time. So I need to somehow get that to have a year attached to it and a time. All right. I've never actually written that much Python in my life. I'm going to go over to my friend ChatGPT and say, hey, you give me a Python function that converts the index column of data frame to datetime objects. The strings are given in the form month/day, hour/minute. And it just does it. It spits out code, even gives me a handy little copy button. That's great. I copy that over. I paste that in. I test it. I see if it works in my data frame. And look at that. Suddenly we have a year attached to it. It seems like it's a datetime. Oh, but wait a minute. Did something wrong. It's not 1900. All this data is from this year. Why is it saying 1900? Well, there's no year attached. But I'm clever. I saw this. I tested it. It didn't work. Before I submit this to my boss, I'm like, hey, you silly AI, that didn't work. That didn't work. My boss is mad at me. Give me a function again, but change it so that the year is always the current year. Awesome. It spits it out. It adds that code. So this is kind of back to that point of it retains context. It knows we're still talking about that original function. It's pretty clever. It's able to recognize we're still talking about the same thing from before and add into it. So I'm not restating everything from the first query. And it gives me this function. All right, let's see what that works. So I copy it over. I think we're on the second one here now. And all right, great. 2023, it looks like we got years. This is the one, sorry. Same code. Yeah. 2023, 1-31, February 1st, February 2nd. We're in business. All right, we move on. We submitted. Our boss is happy. We keep making big bucks, living in the Bay Area. And now we get a little bit later. So now imagine it's New Year's Eve, the end of this year, right? I'm at my big tech job. I'm out at some crazy rooftop party. I'm not paying any attention to work. And then suddenly my phone starts ringing. I'm like, uh-oh, what's happening? What's going wrong? What's going wrong? So the problem is it's a new year. And I told it to just use the current year. And ChatGPT doesn't recognize there's going to be a problem there. It just gives me exactly what I told it to. It did give me what I asked for. But now we have a date that's currently the 31st, but the data it grabs kind of goes, it's a forecast. It shows the next 3 days. And I run that code and everything is 2023. So now what should be January 1st, 2024 is 2023. So now we're overwriting our January data from last year. Everything's breaking down. So again, clever, spits out good code, but it's not having a bigger picture here. It's not maintaining kind of the it doesn't recognize what's going on. So at first I was like, that's great. My boss is happy again. But now New Year's Eve, I'm mad. You stupid AI, the year just changed, stopped working. Now my boss is furious. Update the function that if the current month is January, assume all the December dates are last year. Oh, while you're at it, add another check. If the current month is December, assume all January dates are next year. So that should kind of fix what we got going here, right? It gives me this new code. I'm like, whew, all right. And I'm just need to get going. I submit it. My boss is happy again. And we move on with life. But now this code doesn't even work at all. It's plugging in, it's doing something quite silly. I'm not going to go too deep, but it's basically just swapping the month for the year because it misunderstood my language and what I was telling it how to do. And so now we're getting a year/day with no month. And I don't actually know how Python works. And all of a sudden I'm fired. Not so good. So moral of this, what I'm trying to show you is just blindly asking for questions, telling it to do stuff for you that you don't understand is not going to work. It is not going to figure out the problem domain, make all these assumptions for you, do all this clever stuff. If you know exactly what you're trying to do and you know exactly how to ask the right questions, this can be super useful. So let's see like a more another example here. Not that one. Let's go back to actually talking to it live. So I want to actually learn Python now. This is what I'm going to call kind of proper usage. So I could say, how do I change the, or how do I don't know, modify the index of a data frame in Python. And it's going to give me really thoughtful, useful information. It's not going to write code for me because we can't really trust it to do that, but it's going to give me a nice example of setting index and kind of modifying that index. That's pretty good. Gives me code that I can copy out, test, experiment. It will teach me how to do things. It'll help me find little pieces of information. But if you're trying to write more than a couple lines of code that you don't understand, this is the wrong tool for the job. It's kind of what I'm trying to get the point across. So give me a function that converts the index, or let's say, how would I convert a pandas data frame index to date time objects? So for like something simple like this is a great use of ChatGPT. It's a simple, isolated question where you're probably going to go to Stack Overflow. You're going to read 4 different pages. Maybe you go to the Python docs. Whereas this has probably read a lot of Stack Overflow. It's probably read the Python docs. It can just answer your exact question in one place with an example. So that is really useful. But recognizing all it is doing is language. It's not testing that code. Remember, there's no logical processing going on under the hood. It's not making sure things work. It's not going to run it for you. Look at this. It's even giving me how I format the date time string. So mine was in month, day, day. So I know how to do that right here. And you can even piece together little pieces of logic. So with where you all are at, this is how I would recommend that you try to use these tools. They're really, really powerful as rapid lookup engines for API details that would be time-consuming Google's otherwise. You have one console, one place to ask questions, and it gives you nice little samples to play with, okay? So I'm gonna fast forward, show you kind of the dark magic side of this. I'm a little bit scared to show you because you might get the wrong idea and trust it. So let me see. Yeah, go ahead.
If ChatGPT doesn't have any method of fact checking itself, if I ask it a question, how often should I be fact checking it?
Constantly, with everything, no matter what.
Okay.
With everything. Do not trust it at all, ever, with anything. It's a language model. That's all that it does. It is, so for something like this, it looks pretty good. Again, like maybe there's a chance this is wrong. But with code, I'm going to copy this over and try it immediately. And it's going to run. It's going to do what I think it does. So by fact checking, in this case, I'm going to run its code. I'm going to make sure this in my terminal, in my Python environment, does what it says it does what it's supposed to. And it might get something wrong. So you're not fully trusting this, but I'd say for simple things, it's going to be at least as good as Stack Overflow, which maybe you have mixed experiences there. So it's kind of a bit of a hesitation on how good you think Stack Overflow is. All right, let's fast forward a little bit. You actually know how to code Python. You've done the years, you know the language. I'll show you something that the same problem that I was actually able to get it to solve for me. So I told it to write me a Python function. This function should take in the index pandas data frame. For every element in the series, the function should convert it to a datetime object from a string in the format mm/dd hhmn. Assume the time is given UTC and set the time zone of the new datetime objects. This actually worked. It gave me a function that did what it needed to. I tell it to modify it. And again, I'm being very, very clear. Modify the function to set the year of the datetime object. If the current month is December, set the year to the current year for all dates for the month of grade, like on and on. So I do the algorithmic thinking. I know how this works. I could do this in Python pretty quickly. It's not that I don't know how to do this. It's that for me to go and look up every line of this, several lines of this, I might have to Google. Like I have found the datetime.now function before, but I'd have to go and Google how that works. I have to go look up the API. How do I access the month? How do I access the year? How do I declare a format specifier? How do I tell it to be UTC? All those things are small Googles. Maybe they're only 10 seconds, getting the first Stack Overflow article, and it tells me. But they're all little lookups that I have to do, whereas this can do it if I phrase my question super specifically with carefully chosen language. It can give it to me pretty dang quickly. I can even now handle like, hey, handle the other case if the current month is January. So I'm kind of thinking ahead now. Handle the past year case to make sure that it does what you want it to. And it just adds that if else case and spits it out. So I'm showing you this to kind of demonstrate that once you do know how these languages work, once you are really comfortable in these libraries, it can spit code out that's pretty dang good. That can save you a lot of time. But off the bat, there's several things wrong with this. It imports time delta. It never uses time delta. I have no idea why it did that. Variable names, I don't really like how it does that. Function names, I normally go camel case. There's no docstring. There's no documentation. It does this df.index equal to pd.datetime call. It does that same call 3 different times. I immediately would copy this code, delete the extra import, rename a bunch of stuff, pull out that one line, put that line above it, add a bunch of comments, add a bunch of doc strings, test this code like crazy, and ultimately end up changing it a ton. I am not blindly trusting this code. I'm using it as a rapid lookup for API details that would be really time consuming to Google. I'm trying to be very careful so you don't get the wrong idea and go and submit all your homework assignments with this, because that will not pan out very well for you at all. So I'm trying to think of anything else I want to show on there. Basically, just to kind of summarize some of those points. Don't trust it. AI generated work is not yours. It is plagiarism, and you will be caught. Just please don't forget that. That code is fully plagiarized off Stack Overflow. I will bet you money that I can find almost line for line that sample out there somewhere. The other things, keywords are king, and how you ask matters. So kind of going back to this example, the one that did work for me, at the very top, I'm not just saying, hey, give me a function that converts it to dates. I'm being very explicit. This function takes in an index of the pandas data frame. I already know the types that I'm dealing with. For every element in the series, I know the index is a series. Convert it to a date time object. I know that exists. I know how time zones work. I know how format specifiers work. I might have to Google them and it might be time consuming, but I know exactly how to describe in Python's language what I'm asking for. And that's the only reason this worked out for me, because I'm being very clear with very precise keywords about something I already know how to do. I just don't want to do the extra Googles. So precision and absolutely no ambiguity. So you can get these tools to do really powerful things for you, but only if you recognize their limitations and work within those bounds. Don't trust the output, again. And a couple sources and resources. Any questions that came up out of that immediately? Yeah.
Sort of a question, maybe comment. It seems like something a tool like this would greatly replace, I don't know what the right language would be, like cognitive load. You have an 8-hour workday, and you can write more in plain language rather than in syntax.
Yep.
Your brain would be less tired.
Yep. Absolutely. And I think that speaks to show, I guess, a couple interesting things to highlight. So you may have heard of this, but GitHub has something called GitHub Copilot, where they actually have, so that you don't have to even switch between windows, they have a tool that embeds into, I think it's VS Code is the only one. Maybe somebody can correct me on that. Maybe it's other editors as well. But you give it a comment and it will suggest all of that code for you. So, and I don't personally love GitHub Copilot. I think it just does something that annoy me, but the point being, these tools are still young. I recommend you start playing with them, not because they're necessarily going to give you massive productivity gains now, but because this is where everything is going. This is going to be a crucial part of your workflow. Learning how to use these tools can be really important, and they're going to get increasingly more and more convenient. So yeah, rather than writing a bunch of nitpicky Python or something like this, where a response call in JavaScript is super common. This is going to be the exact same structure every single time. Typing out every curly brace, every comma, every colon, hitting tab a bunch, that's wasted energy. Why should you do that? And it might seem trivial, like I can hit the tab key 4 times, but this is every line of code you ever type. That is thousands of keystrokes every week probably that you're saving just by letting it do the easy parts for you. And again, this does not replace knowing how to code. you are not going to just suddenly be out of a job as a software engineer. There's no way. It is a tool that you can use to shortcut things that are trivial and kind of take off that cognitive load. Like, you're not worried about Googling, all right, what is the format for a response query in JavaScript? It just does that part for you, Googled it for you, and puts what you need there so you can move on and think about the harder conceptual challenges. So yeah, that's a good question. Yeah.
What does Microsoft aim to gain from investing?
Yes, good question. So I don't have a whole lot of context on this, but I can tell you what I know. So OpenAI was an independent kind of research think tank group that's been around for a while, doing a lot of cool stuff. I don't know if Microsoft owns them or is just their major funder, but the main way that they're profiting is through basically software as a service. So they have an API where it's kind of like a URL where I can hit their endpoint with the question, and they will run the query and give me that data back. And they're going to charge me a few pennies every single time I do that. Let's say I'm an airline company and I have my little chatbot that helps you buy flights, right? So I can take that Microsoft endpoint. I can even give it a bunch of starter data to teach it about my flight pricing and all my policies and all this stuff that I wanted to care about, whatever it may be. But after the fact, every time someone is on my website and they're talking to that API endpoint, the little chatbot on my website, it's going to be hitting that API. And they're going to be charging pennies every time. And some of that cost is to pay for their servers, their electricity, their Wi-Fi. Most of that is just profit in their pocket. So they are using this as software, as a service to sell to other developers like you. If you have a clever idea for how to use this, you can develop an app that uses this, but you better be making more money than Microsoft's making off of you. So that's kind of Microsoft's end goal. And there's all sorts of clever, crazy stuff you can do with this. So I think there will be a lot of products coming out of this. I suspect there will be a competitor to GitHub Copilot very, very soon, built on ChatGPT. I would be shocked if there's not. And those will be paid services probably early on that Microsoft will probably get rich off of. I think they're making a very good bet. Yeah.
They also started a fund.
Yeah. What do you mean by clarify?
So they started an investment fund and they're basically investing minority to majority interests in AI companies that will replace generative or creative workers. So to script, which is the tool that is a video tool. They invested in that recently. And so one of their biggest models for making money will be that investment fund, because it's a platform technology that will replace lots and lots of types of workers. The other thing too that you should know is that it's a capped profit model, and they have a separate nonprofit. So after Microsoft makes a certain amount of money, and the investors make a certain amount of money, it's like 100x on what they invest. Then it starts being put into a nonprofit. It's a 501c3 for education.
Good context. Thank you.
Guys, I have to take my computer to my next thing, but I want you to
Sorry,
stick around
Grandma.
and talk to Orion as much as you like with each other. And I'm really proud of each one of you being here and sitting through something that seems maybe large when you're really just getting started, right? But we support each other and we teach each other and we make it together. And so just know that you're a part of that. And then 3 years from now, you're going to be teaching someone else just like Orion. So thanks for being a part of it. Give yourself a big round of applause.
Thanks, Kim. Other questions? Yeah.
Kind of an observation, actually. Like you said,